but here it is. Okay, so you will very soon be quite comfortable with these two, normal CDF and inverse norm. I use these two when values do not appear in the graph. In fact, unless I ask you to graph, I would say go straight to normal CDF or inverse norm. And here's what is gonna, the first part, normal CDF, what it's gonna do is you're gonna give it a start and a stop. You're gonna feed it the mean and the standard deviation. So 4 things that it needs every single time. And it will find out the percentages. So basically, I'll show you here on the iPad. This is what's going to happen, okay? Bear with me. Okay, so you'll feed it the standard deviation, and you will feed the mean to it. So it will know, it'll kind of, imagine it's making a little graph on its own. You just won't see it. And then you will give it a start and a stop, okay? Like, let's say you want to know like the probability of someone having a height of 173.25 and 180, let's say. It'll find the percentage in between. Notice that it's not exactly where we usually split. It's somewhere in between. So you can figure that out exactly, okay? So you can find something in the middle where you have a start and a stop, or you can focus more on I want to know like who's taller than a certain height. So basically from here all the way to the end of this curve, like taller, right? Or I want to find out the top 5% of salaries, like how many people make more than $80,000 a year. You can actually figure out, okay, I just want to know from here all the way to that end, which is, by the way, infinity. I know it's weird, but this curve technically never ever touches the x-axis, okay? Because there's always a chance something is out there. You can also figure out the bottom in terms of income, like who makes less than $45,000 a year, like households. You can actually figure that out using normal CDF, okay? So that's what normal CDF is going to do for us. It's going to figure that out exactly without us having to do a graph. So normal CDF needs lower limit, upper limit, mean, standard deviation. It will calculate the probability that exists between two values. The answer is given as a decimal. We multiply by 100 to get the percentage. Okay, so that's important. It needs 4 entries separated by commas. Okay, lower limit is the value that would be to the left. Upper limit is what would be to the right. And this is a big remember. Okay, I'm going to switch colors here. If z-scores are given, I'll say this many times so you remember, okay? If I give you a z-score instead of like the actual height of a person, you should immediately know that your mean is 0, right? For a z-score, the mean is where 0 is. And the standard deviation is 1. Immediately. Like you should be thinking, I'll do this for you. This is the first time I ever do this. You should immediately think, oh, you're talking about a curve where mean is right down the middle and the standard deviation is 1, right? -1, -2, -3, okay? So this is the big thought that you're going to have, okay? That's the thinking bubble right there. That's what it's supposed to be. Sorry about that. So let's use this thing, okay? Assume that the mean income per household in a city is 45,000 and the standard deviation is 15,000, okay? What percentage of households earn between 32, this is lower, earn between 32 and 65,000? So it gives you a start and a stop, okay? It gives you a lower limit, it gives you an upper limit. So you're going to find percentage in between. I already went ahead, guys. Please stay awake for this part. I already went ahead and made ourselves a little normal distribution curve using this mean and that standard deviation. Now, I'm going to ask yourself, is the 32,000 showing up anywhere in here on the graph? Does 32,000 show up anywhere here? It doesn't, right? So we're kind of stuck. But 32,000 would be somewhere about there. So basically, we're making our own partition here. That's the 32,000. And 65,000 would be where? 65 would be probably somewhere in there. This is just approximately, right? There we go. So we want to figure out, we want to know, like, what is the percentage in between? Every time you want to know probability or percentage, we use Normalcdf. You have to show me this part right here. Normalcdf. You're going to put 32,000 in here. You're going to put 65,000 in there, followed by the mean and standard deviation. I will do this. Whatever this answer is, I'm going to multiply that by 100. Okay? Because I want percentage. So I'm immediately saying, okay, whatever Normalcdf spits out, I'm going to multiply that by 100. So let's do that. How do you access that? I skipped this earlier. You have to press second and vars and then choose Normalcdf. So let's go find that together here. Second vars, go find vars, it's right here. Please don't pick PDF. You want CDF, it's very important. We're not going to use PDF at all. Select Normalcdf and then just type it in. 32,000, comma, 65,000, and so forth. Close the bracket. You've got your 4 entries there. Hit enter. And so I write that down first. 0.7157, and that keeps going. And multiply that by 100. So you either just shift the decimal or multiply this by 100. So you have 71.57. Round to 2 decimals all the time. Okay. So that is the percentage of households that make between 32,000 and 65,000. Okay. This is very simplified, but this is what the government does when they make policies, when they announce like savings on taxes. They kind of look at like how many people would we be benefiting with this, right? Who needs it the most, right? They do this kind of stuff in the background. It's all data-driven decision-making, guys. The government they don't do things randomly, okay? They use stats, they use this knowledge, right? Because income is one of those things that is also normally distributed. Well, you would hope so. I would have to look into that a bit more, but it tends to be, okay? Okay, let's keep going. Here's where it changes a little bit, okay? Watch this. What percentage, so percentage of households earn more than 75,000? More than 75,000. Can I write down at least? I could easily have used the words at least 75,000. You need to become comfortable with that kind of wording. What would you say this is? Is this a lower or an upper limit? 75,000 or more. 75,000 is like the lower limit, right? 75,000 or more. So this is your lower, okay? Lower limit. Let's go ahead and find out where it is on our graph. It actually shows up. Do you see it? It's actually right on here. We're going to use our calculator still. So it's right here. So we want 75,000 or more. Would you agree that more means to the right of this thing? Right? Everything to the right of that curve. I'm going to try to fill in this little thing here. Okay. So let's see here. Normalcdf. This is where it gets a little tricky, but I know I can count on you. What is the upper limit? Is there an upper limit? You might think, oh, Mr. Dirksen, there's a 90,000 there. I'm just going to put the 90,000 in there. No. Just pick a really, really big number. So I just tell, I tell my students most of the time a million works. Okay? So 1 followed by, just pick a really big number, much bigger than what you have here. So I will just say this, pick large number. And I will say that a million works. If you want large, you know what, if you went, 10 million, 100 million, a billion, anything past, like it doesn't change your final answer. You just have to pick something really, really large. So that's your upper, followed by the mean and the standard deviation. And then we're going to multiply our answer by 100. So go ahead and try it. I already used this, so I'm just going to go up, copy, paste. I'm just going to change my numbers. 1, 2, 3, 1, 2, 3, 45,000, 15,000. Wait a minute, sorry, I made a mistake. What is my, this is supposed to be 75,000. My bad. 75, there we go. That is my answer for now as a decimal. So this is equal to 0.0227 something. Multiply that by 100 or shift the decimal. 2.28% of households in this city, only 2.28% of households make more than 75,000. And I want to bring this up because you might say, wait a minute, what's 2.35 plus 0.15? What is that? It's 2.5%, right? If you had used the graph, you would have had 2.5 as your answer here. And here's what I have to tell you, that what we were doing is an estimation. Okay, if you just quickly want to estimate, you use just your graph, but let's be honest, most of the time you're going to rely on technology to find out exactly, right? This is exact amount, exact percentage if using calculator, okay? So you'll see that there's a bit of a variation between using the calculator and using the graph, and that's okay. I will highlight this part, guys, because this one right here, make sure you highlight that so you know you picked a large number. Next, what percentage of households earn less than 39,000? Let's write this a different way. At most, 39,000, that's what this is saying. At most, like the highest income that someone is earning is 39,000, and so we're considering 39,000 and below. So let's go to our graph here. 39,000 is right about there. It's just an approximation, right? This is 39,000. And we want, right, this or less. So we're basically interested in all of this under the curve, That's why we're interested. So what is this, upper or lower limit? Meaning like going from left to right, this is your upper limit. So left is lower limit, to the right is upper limit, okay? So we go normal CDF. What is my lower limit? Like what is low? What would you say? Pick a really, really small number. So I'll go negative 1 million. Right? Like negative 1 million is like so far off this page, it's like super, super low. But then you're making sure that this tail, as far as it goes, you're making sure you account for everything. And then this upper is 39,000, followed by mean and standard deviation. And you go times 100. So I'm going to call second vars again. I'm going to redo this. I don't want to use a previous. So negative, make sure you use negative, not minus. And I hope this doesn't stress you, the picking, and every time you give options, students panic a little bit. It's like, no, feel free to use whatever. So this is, if you multiply this by 100, you get 34.46%. So you're finding the percentages. Let me see here if I can ask you to try this right away. 34. I have inverse norm to do yet, but I'm going to first let you practice this a little bit. Yes, it needs practice. That's just how you're going to get better. I'm going to ask you to skip making your normal curve. We're going to pretend this question was never asked. Okay, so I will say for now omit, because I know you know how to do your normal curve for now. I want you to use technology, which means use your calculator, to answer the following. Okay? If you need to make a little sketch on the side, I'm fine with that. I'm totally fine with that. But I want you to calculate the probability or percentage of bags, potato chips, which I love, okay, between here and here. And remember, you know your mean and you know your standard deviation. Let's just write it down one more time. 250 and 5, okay? So normal CDF has to have this at the end. Except for, if I give you a z-score, what are these two? 0 and 1. If I give you a z-score, you know your mean is 0 and your standard deviation is 1. But you're not going to come across that right now. Try 34. E you should also be able to do. If you can't do E, just wait for me a little bit. But for now, B, C, and D is something I want you to practice. Write down normal CDF. Show me what you're putting in there on paper, and then try it out. Okay? All right. All right, so if you follow along, correct, do whatever you need to do. The probability, percentage, right? Likelihood of bars weighing between this and this. For now, all we know is normal CDF, but the fact that it's asking for percentage tells you that it's going to be normal CDF. 232, 273, it gives you an upper and a lower. These are usually easier to handle. 250 and 5. Okay, so if you do that, you get, oh, I should multiply this by 100. You get 99.98% of bags weigh between those two limits. Percentage of bags heavier than 257. Can we translate this real quick here? Heavier means at least 257, because I will use this wording a lot. Okay, so sometimes students don't know what to do with at least. What does that mean? At least means heavier than 257 or more. Okay, so normal CDF, and you go 257, that's my lower. You go 1,000,000, or if you like more zeros, you just put another 6 zeros behind it. I don't know how much the calculator can handle. Don't make it crash, right? The more you do it, it might crash, who knows? 255. Can I just say something? I don't want you to just blindly use 1,000,000. Let's say we're talking about income, and I ask you, what percentage of households make more than $1,000,000? Oh, 1,000,000. Would you put 1,000,000 here? No, it's like the same. Like then you have to go bigger, right? You have to go, okay, I'm gonna add a few more zeros to make sure I have something way out there. So please don't think it's always 1,000,000, but 1,000,000 works 99.9% of the time, okay? So times 100, here you should get 8.08%, okay? There we go. Bags weighing less than this. This is kind of saying at most 243.5. Okay, so we would go normal CDF, and in this case we're going to go a really small number, and this is our upper limit, 255. Okay, unless I ask you to graph, guys, we're always going to use calculators. Okay, unless I ask you to graph, you're going to use normal CDF from now on. This is going to give you 9.68%. Okay, so that is your answer. Now, this one, we already touched on this one when we started this this chapter. Okay, the company disposes of any bags that weigh less than 239 or any bags that weigh more than 262. So let's make our little sketch here. So we're disposing of anything that weighs less than this, and this is just a sketch, it's not a detailed graph, okay? But anything less than 239 and anything more than 262. So we need to figure out the percentage that is here and the percentage that is there. Okay? Now follow my train of thought here. First of all, it says what percentage of bags would be disposed of. There are two ways to do this, the hard way and the easy way. What is the percentage under the entire curve always? 100%, right guys? Under the entire curve is 100%. So what I'm going to do is, I'm going to find the percentage between here and here and subtract that from 100 to be left with the tails. That's one way of doing it. Or you can do a normal CDF for this and a normal CDF for that, and then just simply add your answers together, whichever one you want. I'll do the harder one first. Method 1. I'm going to go normal CDF, negative 1,000,000, 239, 255, plus normal CDF. Slow down, Mr. Dirksen, slow down. So this part, right, this is this one right here, where I have my upper limit and I want everything to the left of it. Got it? So those are being disposed of. But we're also disposing of the top end here, the heavier bags. So that's where you got to go 262 and positive million, 255. I'm going to put the answers for now as a decimal right beside each other. So I know lots of arrows flying here all around, but right, so that's that. So let's figure this out. I did it the other way, so I'm going to show you second vars, normal CDF. Okay, let's do this one first. 0.0139. Dot, dot, dot. And this part, the next part, second vars, it's easier for me to just go second vars again, to be honest. 262, comma, 1,000,000, 250, and 5. Get the answer there, 0.0081, very small number. Yeah. I went more than 1 million? What if I told you I did that on purpose? Do you get the same answer, you think? Here. You're saying there's one too many zeros, right? Because I'm not really thinking about it. You're going to get the same answer. You want to get rid of one more zero? Because you're so far up there, right? If you drew your normal curve, if 250 is your average, you're going 255, 260, 265. If you pick 1,000,000 or 10,000 or anything, you're so far out to the right. It's taking care of everything. Okay? So that's a good observation. I didn't know anybody. I sometimes don't even think about it. I just go a bunch of zeros and then just hit enter. Okay? 0.008 something. I want to do inverse norm. That's why I'm hurrying a little bit. Add those things up. Okay, so I'm going to go copy. Use all decimals as you're working. Okay, so copy, paste, add it up. That gets you 0.0221 something. I'm going to multiply that by 100. That's 2.21%. That is what you're disposing. Very small percentage of bags, right? Very small, but there's always a little bit of waste. This is method 1, okay? And here's my favorite one though. Method 2, you go 100%. No, I'm going to go 1. Sorry. I'm going to go 1 minus good bags. And I'm going to use a highlighter here. What do you mean good bags? Would you agree with me that this section right here are the ones we're keeping, right? We're not disposing. These are good. Why 1? Because the curve is 100%, right? As a decimal, it would just be 1. I'm going to go 1 minus, watch this. If you can wrap your head around this, it's going to save you a lot of time. This part right here, if we wanted this, we would go 239 to 262, 250, 5. I'm going to show my work here. I'm going to go 1 minus the good ones is 0.9778, and that keeps going, which gives you 0.221, sorry, 0.0221 something. If you multiply that by 100, you also get 2.21%. So regardless of what worked for you, you would be okay there. So indirect, one is called indirect reasoning. where you go, you know your total, so you subtract what you don't wanna consider. The other one is direct reasoning, where you find what you want and then add it up, right? More on that in grade 12 applied, okay? Indirect, direct reasoning, we use that a lot. Especially when it's probability. Okay, keep going. Oh no, that is to be continued. Let's go back to inverse norm, page 33. You're gonna work on the next page once I'm done with inverse norm. And then tomorrow we'll do a study sheet entry for these guys, okay? Next one is inverse norm. Percentage of data below X, mean, and standard deviation. How many entries? Only 3. You got to make sure, let's put an arrow here, you have to go as a decimal. Some students just put in the percentage, but this has to be turned into a decimal. So if I give you 80%, you have to go 0.8. Okay? We'll calculate, what does it do? It will calculate the actual value along the x-axis we're looking for. And here you have to just remember a few things. If 35% of people earn more than $50,000 per year, I'll say this again, 35 make more than a certain amount, that means that we're looking at something to the right, because it's more than. So you're saying that percentage is above this. Okay, I will say this. Above 35% above $50,000. That's, please write this down. More than is above, or you should realize, how should I say this, guys? I'm going a little fast, but I'll do this again tomorrow, okay? What is the entire curve always made out of? 100%, right? If I tell you that 35% make more than 50,000, wouldn't it make sense that the 50,000 should be higher up here? Because we're saying that 35,000 is over here. Like it's a smaller percentage compared to the rest. It's 100% all over, okay? If this is 35%, what is this going to be, like this chunk right here? Mental math? 65%. Okay? So you kind of in your head, you should be able to break this always down into 2 regions. If I give you a percentage, you're like, wait a minute, where should this be? Is it going to be higher up? 35 is above. That means that this imaginary line is going to be higher up because 35% is smaller than 65, right, which is below. So first things you got to ask yourself, is this percentage that I'm given above or below the number being 50,000? And then you put it in the right place accordingly. More. Let's do another one. If 42% of students spend less than 15 minutes on homework, then less means what? Wouldn't you say it means below? Less is below. And 42%. So 42% below 15 minutes. Where would you cut this curve, guys? Where would you cut it? Let's try this a little bit. Middle, if you cut it in the middle, what are we saying? 50, 50, right? If 42% are below, would you take this line higher up or would you bring it down? What would your instinct tell you? Where would we slice it up? I would suggest we slice it up here, because then it makes sense that 42% is here, because we know by reading it that the 42% is below it, meaning to the left. which means that this side here is going to be 58%. Got it? Maybe not yet. To be continued tomorrow, okay? You're going to practice though. This is what inverse norm though is very keen on. I'm going to use a highlighter here, okay? Inverse norm, highlight this with a different color. Inverse norm only ever cares about the left side of the value you're trying to find. Think of Beyonce's song, To the Left, to the Left. Right? I'm not going to sing it because it's going to ruin it, okay? This is 50,000. Sorry, I also meant to say that technically then we know that the 15-minute mark is here somewhere. So imagine along the x-axis we have like time spent on homework, which for you probably is way higher than 15 minutes. It's way higher than 0 minutes or something like that. Anyways, let's practice this now, okay? I'm doing this just to help you out. You don't need to do this every time, but I will do this a lot, a little sketch. Okay, this income, we don't know what it is, would have 30% of household earning less. Read it and ask yourself, is it 30% above or below the line that I'm going to use to slice this curve? Earning less, what would you think? Below, right? Below. Let's just keep that for now and let's slice it up. If it's 30% is below, then it stands to reason that there's a smaller chunk of the curve to the left as opposed to the right. So we make this 30%, which means this is 70%. Always remember that. Inverse norm does not care about the 70, to be honest. I might ask you for it at times, but inverse norm cares about this one. It only cares about what's to the left. And you're asked, what is that income? Like, what is this value here that would have 30% of families making less than it? What is that? So we can do this. Inverse norm. We're not going to feed 30%. We're going to feed 0.30. Remember that. And then the average is still the same as before. 45,000, 15,000. I'm going to highlight this orange or whatever color you're using to highlight the left. And so let's figure it out here. I go second vars, and then you go inverse norm. And we go 0.3, 45,000, 15,000. You're not getting a percentage here. You're actually finding the value along the x-axis. So you get 37, we're talking income, right? 37,133.99. That income, which you just found right here, it was an unknown not too long ago, but that is the income that would like line up with that slice. If you were to slice it up here, you would have that income down here. So 30% of families make less than that, 70% of families make more than that. But inverse norm doesn't care about the 70, it only cares about this. Okay? Okay, let's do another one. And then I'll call it a day. An income of question mark would place a household in the top 20% of household incomes. Please just stay alert for this one more example. If you're thinking top 20, where are you thinking on the curve? Is it here or is it here? Top, right? Top is here. This would be bottom 20%. So 20% is right here. Yeah. Do we care about the 20%? Can we feed that into inverse norm? No. If this is 20, then what is this? This whole chunk here. 80. Yes. That is the one we care about. Hold on. Let's make this even more. Let's make sure we understand. Top 20% is that. So yes, it's part of the work. You need that number to help you out. And then we figure out to the left. So we're figuring out what is that income that would make this happen. We're not asking for percentage. We're asking for actual income. Actual height. It could be actual height. It could be anything actual. Then you use inverse norm. We go 0.80, 45,000, 15,000, and voila, you're going to get the answer. Okay. I'll copy paste this one. This one is easy to copy paste. Change that with 0.8. That would be 57,624.32. Okay. I'll squeeze this one in so I can say I finished this one. Sorry. 45% of households earn more. Earn more is above. 45% earn more. It's almost 50. If you sliced it here, it would be 50-50. So this would be slightly over here. You slice it up and you realize that the 45% you're given is here. But you don't care about the 45, correct? You care about this one. This is 55%. So guess what you would use? You'd use inverse norm. 0.55, 45,000, 15,000. You got saved by the bell. 46,884.92. If you could try pages 34 to 36, try using Normalcdf inverse norm, okay? Thank you guys.